Good morning, everybody. First of all, I would like to welcome you all to this Mingguan Science Tenggara, Unveiling the Wonders of Chemistry. Today's topic will be harvesting energy from sun with chemistry. I'm the moderator for this morning session, and this session is going to be presented by our Professor Dr. Juan Jun Chong. Before we proceed further, I'm Dato Dr. Yu Chong Hui and the council member of Institute Kimia Malaysia. We are glad that you are able to join this session to share with Professor Dr. Juan with regard to harvesting energy from sun with chemistry. Now, let me just introduce briefly the speaker for this morning. Professor Dr. Juan Jun Chong is a professor of nanomaterial and catalysis at University Malaya, Malaysia. He is also the chair founder, Frontier Natural World Cluster, and head of international cooperation relation at University Malaya. He obtained his PhD from UKM in the year 2007. Now his research activity focus more on nanostructure. He have a lot of publication, more than 200 of them, and high indexes of 47 or and more among the more than 10,000 citations. In fact, he has a very impressive CV, I will say that. And he also is very active in many professional organizations, and and he has been also been recognized as the top 2% scientist in the world by Stanford University in 2002 to 2020, and top 10 outstanding young Malaysian Award 2020 by Junior Chamber International. And these are all very excellent and renowned awards. In addition to that, he is also the council member of Institute Kimia Malaysia. He is also the secretary in not only in Malaysia scenario, he is also actively participated and involved in international professional organizations such as FACS, ISC, and many, many more. So if I were to read all his, I think, CV, yeah, it will take about 15 minutes, then we don't have the time for the talk. So anyway, Professor Dr. Joan, we are glad to have you, such a, I would say, very impressive professor in the young generation. Without much ado, I would like to invite Professor Dr. Joan to deliver his talk on harvesting energy from sun with chemistry. How to use that. Thank you.
Thank you, Dato' Yu, my fellow council member. Dato' Yu also one of my good friends, I can say, and mentor. I've been knowing Dato' Yu for more than 10 years. So I'm very honored to be here today under invitation of IKM Institute Kimia Malaysia. So today I will talk about the what we call harvesting energy from the sun. I think everyone here know about sun energy, but I will go more detail about how chemistry can utilize the energy from the sunlight. So I'm from University Malaya. I don't have to go into details, so I think everyone know that the University Malaya is actually at the what we call capital of Malaysia, Kuala Lumpur. Okay. So this is a biography that have been presented just now by Dato' Yu, brief introductions. So the thing that I would like to talk up is that I working in various area. In my research interest is on wastewater catalyst. I will talk about this energy, environmental, and I also prepare some nanomaterial for as additive and also for rubber industry. So this is my some of these achievements. I also awarded 2016 which is the National Scientist on by MOSTI, Minister of Science and Technology and Innovations, and then further National Academic by Future Academicians by Minister of Education MOE at 2018. So at 2020, I'm one of the top 10 outstanding young Malaysian by the JCI. Of course, I also quite active as a young people, as mentioned by Dato' Yu. So quite active. I also involved in many activities many CSR activities, and also very active in the IKM Institute Timah, Malaysia. So this is some of the recognitions and also some of this sharing of my research and also some of the work that I have done so far and have been reported in the media. Come back to our topic today. So I will give a very brief sharing on the sunlight. What is the sunlight? Okay, what is sun? And then I will zoom into a photocatalyst that using the sun, okay, to do a chemistry. So it's a photo means light, catalysis means what we call way to accelerate the chemical reactions. So then we will go to the what we call my research, how I utilize this material to do more chemistries and to treat wastewater. So finally is the conclusion. So let's start with some introduction on the sunlight energy. So everyone here know about sun. Okay, this is something that everyone's uh, you know exposed to, right? Okay, today you go outside of this room or you in the hall, you go outside, you exposed to the sun. Okay, you cannot escape the sun, and sun is what we have been here for 4.5 billion years ago. Okay, and you can see the surface of suns if keep emitting photon or light, and this is due to the fusion. Okay, this fusion is basically what happened is two protons with hydrogens have been fused together, bombard together, become the helium. Okay, this fusion occur in the sun every second. Okay, and you can see the temperature on the surface of the sun is about 4,500 degrees C. So how hot is it? Like 100 degrees C, you put your hand into boiling waters, which is 80 to 100 degrees C, you will get burn, severe burn. So this is 4,000 times, 40 times, okay, 4,000 degrees C, okay. So this is a very intensive, what I call temperature. And every day, okay, every second, I can say that about 3.8 times power 26 watts. This energy, how we calculate energy, that's the electricity you use in your house, right? Okay, this is, we calculate energy based on the watt, W. So what happened here is uh, roughly every second, 3.8 10 power of 26, a huge amount of energy is bombarded into our Earth, okay? And when you talk about photons, if you are studying physics, right? So people like to talk about photons. So how many photons that bombard onto the Earth is 1 and power 45 or 45 photon leaving the sun every second. Okay, every second. So every second, there are so much of the energy released from the suns and hit the Earth, our planet Earth. So we must what is you can't if you can't imagine the amount of energy, okay, about 3.8 times power of 26 is about 9 times power of 10 megatons of TNT. Okay, so this is the amount of energy released by the sun every second. Okay, the huge amount of energy. So if you can't imagine this energy, so I will be simplify it. Okay, so the total energy hitting the sun 1 hour, okay, 1 hour, okay, is 173,000 terawatt hours. Okay, this is 1 hour. So every hour that you calculate 1 hour, so this amount of energy, 173,000 terawatts, okay, received by the Earth. And you can see every year, the humans are only utilize 160,000 terawatts. Okay. So this including electricity, our heating, coal, gas, our transport, and also for industry, our industry process. So this is the amount of thing that we utilize so far. So this is huge amount of energy heating the earth. That means in short, 1 hour of you can capture the whole energy from the sun. 1 hour is enough energy for the whole year. This is the amount of energy released by the sun. So the question is, can we capture or can we harvest or can we utilize the energy from the sun? Okay. So this is the sun energy. So to me, a solar energy, sun energy, or we name it as solar energy, referring to capturing and harnessing or harvesting the energy from the sun. Okay. So there are two ways that we can utilize sustainable energy. We call it because sun is free. Okay. Everything almost under the sun. So there are two ways to we can harness the energy from the sun. Number one is direct. Okay. This is very obvious using a thermal methods. So we are using a solar radiations absorbed onto a solar collector. So if you look at the roof of some of these house, you can see a heater here, water heater. So when the sun hit this panel, they hit the water heater. So this will provide hot water and sometimes electricity to heat the to give you a warm water. So this directly utilize the sun energy. See, that means you harvesting the sun energy by absorbing the heat, okay, radiation from the sun. Second method is called photovoltaics. I think everyone know about this solar cell, okay, or PV, photovoltaic cell. That is quite good because it's very sustainable. You need a solar panels, okay. You can have solar panel farm, and then what happens? The sunlight, okay, in terms of photons will hit the solar panels, and this band gap semiconductor normally will utilize become a electricity. So this is called photovoltaic effect. So the sunlight can be transformed directly into a electricity. Okay, so a lot of people did not know the indirect sun energy. Okay, even the wind, okay, or tidal energy, you have a wind turbine, right? Okay, you have a wind turbine. The wind actually also contribute by the sun indirectly. What do you mean indirectly? If not directly, okay, uh, indirect. That means the atmospheric air heated up by the sun. Then the air lifted up and the cold air take into previous state. This create a circulation. So this create a wind. Okay, so the wind that you are having now, beside the rotation of the planet Earth, they also contribute by the sun through this atmosphere heating up. Okay, so this is indirect energy from the sun. Okay, so then we have a wave or tidal. A lot of people thought is just movement of the gravity from the moon and the sun. Beside that, wind also produced by the created by the wind movement. So these two is related. Okay, so you have just now I mentioned the wind is created by the sun. So this tidal also actually created by the wind movements. So that's also create this tidal and wave. So we can utilize this tidal energy to become electricity. So it will turn the turbine, just like the wind turbine, they turn the fan, turn the turbine, and create the energy from kinetic energy into a electricity. Another one, biomass. Okay, without the sun's, the what we call plants are unable to conduct the photosynthesis. So photosynthesis is basically utilize the sun energy and create the carbohydrates. Okay, so a lot of biomass or all plants, our trees survive using the photosynthesis. So the plant receives the energy from the sun and then used to produce the biomass. So this is also that people are turning this biomass, for example, sugarcane into ethanol and then into a fuel. Also, some was using oil, waste oil, palm oil, cooking oil, waste cooking oil, algae oil, which is our thing that make a hoo-ha here. Because they have this algae can do a photosynthesis, and then we can squeeze the oil from this algae and make into a biofuel. And then hydro energy. Okay. Hydrogen is not water. People thought it's a water. Hydro is water. Basically, without sun, we do not have hydro. Why I say so? Because rainwater get vaporized by solar heat. That means the sun shine onto any water, it will vaporize. And then it's condensed and from cloud and condense and have your rainwater. So without the sun, we cannot have the rainwater and we do not have the hydro energy. So basically the indirect 1, 2, 3, 4 is indirectly from the sun. Okay. So how as a chemist, how are we going to utilize this what we call as solar energy or sun energy? So for my research, talking more to more my research, so I would like to have a clean water. Okay, hey, you can look at this photo. This is a waste water. Sorry. So this is a wastewater treatment plants. Okay, you can see that there are huge wastewater treatment plants. Okay, what technology can be utilized or more sustainable be utilized to treat the wastewater from wastewater to a clean water. So this clean water will be for our daily use, for example, drinking water or for us to take a shower. So at this current moment, this is something that people are looking at how to treat the wastewater. One of the most common methods is use the adsorbents. So this is commonly used way to treat the wastewater adsorbents. A lot of people are using charcoal, biochar to treat the wastewater because all the pollutants will be absorbed onto this absorbent, for example, charcoal. Okay, and membrane filtration is very common being used because they can filter off all the organic pollutant or pollutant, just like any drinking water machine you have in your house, for example, certain brands, okay, using a membrane. Yeah, okay, there are few membranes, okay, in your house filter that can filter off all these pollutants. But this come with one problem is very expensive, and when you filter off these pollutants, what it left up is slush. Okay, so it accumulated as a slush. So people are trying ultrasonic destructions, but this is very energy intensive because you utilize electricity. Enzyme is something people look at it, but still impractical because enzyme is very expensive to prepare, and you want to extract enzyme also quite expensive. You involve a lot of software and technology. Chemical treatment is also currently basically being used so far as a chemist. They use a lot of coagulants, flocculants, but the problem is it creates a lot of slush. Okay, the slush is something that we trying to reduce or remove from our chemical treatment plants because slush is another pollutant. You remove all the organic pollutants from this wastewater, you create another solid waste or solid pollutants. So it's something that we try to remove or reduce. So one of the more practical way is using a photocatalysis. So what is photocatalysis? I will go in details, but this photocatalysis based on literature is a low toxicity, cheap, and it creates no slush because all the organic pollutant will be uh, degraded, okay, or decomposed into a carbon dioxide water. So what is the photocatalyst? We go to a more about bit about chemistry here. What is photocatalysis? Basically, they are using sunlight. If you look at the photo here, right photo here, this is a leaf. Of course, they have a chlorophyll, and chlorophyll can do the photosynthesis. Photosynthesis basically using the light energy and convert into a carbohydrate. Okay, so photosynthesis, it creates a carbohydrate as a food for these plants. So this has been uh, utilized by our plants billion years ago through revolutions. They're quite smart. They create a pigment called chlorophyll that utilize the sunlight and create a lot of this what we call carbohydrate food. As a chemist, what we want to do is using the sunlight on this photocatalyst, but not creating the carbohydrate as a food, but to create this radical. Okay, this radical. What is radicals? Unpaired electrons. Unpaired electrons is very active and it can degrade all these harmful organic pollutants into CO2 plus water. So basically, what happens here? All these organic pollutants will be destroyed, okay, into carbon dioxide and water. So basically, we can use the or sun energy to create radical and decompose the organic pollutants. This is what the topic we are talking here today, photocatalysis. So at this moment, there are certain commercial type of photo can be used. It's a P25. Basically, they're using sunlight. Okay, but the disadvantages, everything is good, okay, only have three advantages. It's cheap, economical, non-toxic, okay. This is titanium dioxide, okay, or titanium. So what is the limitation? Its limitations is only can be activated under UV light because the band gap, this is the band gap. When the light shine on it, the electrons must overcome this band gap And this band gap is 3.2 eV, quite huge. And only UV, which should have a higher energy, can activate this titanium. So to utilize, most of the light is 46% is visible light and 49% is infrared. So we must at least utilize the visible light because the UV only 5%, and this commonly found the output only can utilize the UV light. So we are trying to research into using the visible light. Second problem is fast electron propagation at low surface area. To increase the what we call the photoactivity to create more radical. As just now we remember, to create more radical, we must have a slow electron recombination, so more radical will be created. Second, we must have a high surface area, so more radical will be created. Okay, so these three challenges, we must overcome these challenges. Three challenges to produce a high activity to create pollutants. So this is something strategy 1 to 8. I don't want to go in details. It's very scientific. So what we do here in our research, we have created a new catalyst, okay, to increase the photoactivity or photocatalyst activities. So what we come to find out is by doping, we want to the strategy is by doping, we put in an iron Fe ferrum and can reduce the band gap. So when the band gap reduced, we can extend to a visible light, and Fe doping with the mesopause material can increase the surface area. So these two strategies we are using. Okay. So as a chemist, we have to go to lab and prepare our catalyst. So most of the chemists have to go back to lab and prepare our catalyst and our studies. So this is where chemists come into a picture, prepare the catalyst and prepare all the synthesis material. After preparing, we have to verify whether what we prepare is correct. So we use all these instruments to help us to understand what we have prepared and whether this type of material is good for our photocatalysis. So then we test our activity using this photoreactor. So this is something that we use, the instrument that we use, XRD. Just now we should show you the XRD machines because we want to verify what type of thing that we have prepared. As mentioned just now, I want to prepare an anatase and brochite phase so they can have a better photoactivities. And so also I also need to put the iron inside to reduce the band gap so it can be visible. So this is some of the study we have done so far to verify what we have prepared is correct. So based on these instruments, we have prepared a correct catalyst with the anatase and brochite phase because you can see from the pic. Okay, so I study a bit of this chemistry here. So this is the pic for the what we call the brochite. Okay, and then this is the anatase. So we have managed to prepare some brochite and anatase phase. So this is the surface area because we need to know how big is the surface area. Bigger is better. So we use some nitrogen sorption techniques to look at the curve. And based on this curve, we know this is the mesopause material and the surface area by calculating peak or the curve behind this peak. And then, of course, we use the TEM, thermal electron microscope, to understand the lattice because it gives the information, the size of the catalyst that we prepare in the nanotech is 5 nanometers. So this technology this instrument can zoom into 5 nanometers. So this is very intensive zooming, and then we can study the band gap as well. As mentioned just now, it can be we need to reduce the band gap from 3, it can reduce to 1.6, which is extend to a visible light region. So this some activity we use the photoreactors, and it can regulate completely, okay, in 30 minutes by using this photocatalyst. And we study about chemistry, how this regulates. Just now I mentioned how this radical works. Okay, so this is how the radical works. We generate electrons, so it creates the superoxide radicals, hydroxyl radicals. So this superoxide radical will degrade the what we call the pollutants that we mentioned just now. So into a CO2 plus H2O. It's a bit complex, but basically we are creating the radical, and because in the water also has H2O, we also manage to create another hydroxyl radical to degrade the organic pollutants. This is something that we understand. So using the conventional techniques, yeah, this is the P25. They managed to create radical and what we call organic pollutants, but it only active under UV light only. By far that we prepare here is a visible active catalyst. Okay, we can use visible light to create all these radicals to degrade the organic pollutants. And then in technology side, we have prepared what we call these patented technologies to what we call to clean the wastewater. So this is something that we do it in a blue color dye, and then we have managed to clean this dye into colors, what we call wastewater. So this is something that we are doing now. Okay, to scale up this technology so it can beneficial to humanity. So next time, the wastewater will be cleaned using a more sustainable way instead of creating a huge amount of sludge that are solid waste that pollute our environments. So basically what happened here, we put the catalyst on this one. And this is a helix, so that actually increase the surface area and get the light can shine onto the photocatalyst. So the conclusion is energy from the sun could be transferred into radical and decompose all these organic pollutant in the wastewater. So this create a more sustainable, cost-effective way of treating the wastewater. So I want to thank my researcher and all these grant directives so far. So thank you very much. If any questions, you may ask anything. Thank you.
Thank you, Professor Dr. Chuan, for your interesting talk on harvesting energy from sun with chemistry. We know energy
Sorry,
is
that's one more time.
uh, that's why we start slightly late. It's okay. So we harvest energy from anywhere. You need to pay. Only you harvest energy from sun, you don't have to pay the cost for that radiation down. However, no doubt the gadget of it you need to really prepare and how to design it. So this is one of the way maybe we can save energy, and it's one of the best ways so far I can see. Huh? So I think Joan, you're going on the correct perspective, and anybody who are interested in doing this can contact you. I think you are doing a good research. So until now, is there any question from the participants? So if there's no question, Professor Dr. Juan, thank you very much for your
Okay.
interesting talk. As time is also against us, now it's almost going to be
Yeah.
10:40. I think we'll give the floor to our Associate Professor Dr. Fatima for another topic to share with the audience. Thank you again,
Okay.
Professor Dr. Juan. Excellent talk. All the best. Thank you.
Thank you. Thank you, Dato. Thank you very much.
Good morning again, and welcome back to all the participants who are following our this series, Mingguan Science Malay Negara. The second series of this talk is going to be delivered by Associate Professor Dr. Fatima Salim, and her talk is very interesting: chemicals in your food. So at least you know what is in your food. Uh, this morning, I will be the moderator for Associate Professor Dr. Fatima Salim, and I'm Dr. Yu Chong Hui, and he's also the council member of Institute Kimia Malaysia. Before we proceed further on the topic of the talk, let me just introduce Associate Professor Dr. Fatima to you all. Associate Professor Dr. Fatima is a lecturer from UITN, University Technology, Mara, and a research fellow at Atta El Rahman Institute for Natural Product Discovery. Her research covers chemistry of natural products, those natural products she was taking care of from plants and microorganisms, and computational chemistry in modeling molecular spectroscopy and binding interaction between molecules. You don't worry, these are all quite high technical terms. You join chemistry, you say, these are all my good friends. She's also she's also a council member of Institute Kimia Malaysia, very active, and even though I know her for not more than 5 years, but I think I've interacted with her. I know she's very active, and she joined many professional body and associations such as the Young Scientist Network Academy of Science Malaysia (YSN ASM) and the organizing chair for National Science Challenge 2023. She's also the ESCO member for Malaysian Natural Product Society, and she's very active in computing science on her Facebook to public by the trade name called Ali Kimia. Memang Ali Kimia means chemist lah, huh? To lay people, she's a founding member of Facebook group Makma Makanan, Mama. So yang suka makan, this is the best forum lah. Her visibility has improved and her credibility as a chemist allow her to reach more public social media users. So upon Googling Ali Kimia Fatima Salim, many news and web pages quoted her response to the issue that captured public attention, which is not only elevate the conversation with her intersect science and society, but also help expand the impact of chemistry beyond the limits of the laboratory. And due to her society contribution, she's also listed as one of the 20 most inspiring women in 2022 by Aura Mingguan Wanita. Congratulations, Associate Professor Dr. Fatima. And you still look so young, and she's already an Associate Professor. So you should know how dynamic and active and professional she is. So without much ado, I would want to take away much of your time, Associate Professor Fatima. So let you share your interesting topic to the audience that is on chemicals in your food. All yours. Thank you.
Right. Thank you very much, Dr. Yu, for your kind introduction. Hi, everyone. I hope all of you are doing well there. And after listening to a talk by Prof. Juan just now, we're going to venture more into the chemistry. Right. So, as mentioned by Dr. Yu just now, I'm going to bring you in deeper into chemicals in your food. Right. So basically, a little bit introduction. I just want you all to know that nothing in this world is actually free from chemical. Why that so? Because chemistry play a very big part in our daily life. They are actually in the food that we eat, the air that we breathe, the product that we wear every day, our emotions, our brain chemistry, every object that we see and we touch, including us. Why I'm saying that? So I'm just going to bring you a little bit on where actually our all of the things that we can see in our bare eyes came from. So basically, we know that everything came from atom. So atom going to combine to form molecules that they're going to be systematically combined together to form cells that go to your tissue, organ, body, organism, population, community into the ecosystem. So this is how we know that nothing in this world is actually free from chemicals. So, what is actually chemical? So, chemicals is substance formed from the fusion of atom in the periodic table. I believe those who are learning chemistry, they are very familiar with this periodic table. Okay, so far we have 118 elements or atom that actually been discovered. So everything that we discovered from this earth, so the chemist going to put it in the periodic table according to their reactivity. So we have the group and we also have the period where the reactivity is based on these properties. Now, again, moving to chemicals, because I believe just now you know that um, all of the things that we can see in our daily life, we as well are chemicals. So I just want to bring you a little bit closer to chemicals. Okay, so chemicals is actually the substance that fused together in the periodic table just now. So they're going to form substances, right? So how do we know that actually this substance exists? So actually we can vision that. We can see by using our bare eyes. We know that whenever there is a chemical reaction occur, there might be changes in color. So previously going to be yellow and then it turned to red. So we know that there are chemical reactions. Okay. And we can hear them. We can hear, for instance, in an experiment, we know the hydrogen gas is produced when you put lighter gas, are going to give you pop. It's going to give a smell, taste, as well as touch. So as I believe most of you know that when we talk about chemistry, everyone will think about bomb, right? So the first example that I'm going to give you is our reactive metal, which is sodium. So it's going to react with water, and then due to Coulomb reaction, so it's going to explode. So this is the type of chemical reaction that you can vision, right? Next is by hearing. If you just open your carbonated drink, so that fizz sounds that you can hear is actually the release of carbon dioxide. So in carbonated drink, um, it's been commercialized where the carbon dioxide been put inside in a very low temperature. So whenever we have differences in atmospheric pressure, and all the carbon dioxide going to be released. So that is the fizzing sound that you can hear when you open your Coca-Cola or any carbonated drink, right? And next is going to be closer to the food, right? So if you like to cook, or you don't like to cook, you just went into any restaurant, so you can hear that fizzing sounds, um for instance, here we have garlic. So the garlic is actually been fried in an oil. So the color going to change from pale and then turn into slightly yellow. That is because of the Maillard reaction that happening, giving us different flavors as well as smell. So that particular smells, most of them going to be sulfurous compound. They evaporate and then they reach our nose that we can smell that palatable taste of it, right? Now, moving forward, perception towards chemical. So most people believe that there are many types of chemical, of course, right? So basically, in a chemistry world, we know that there are two types of chemical. One can be synthetic, which is actually made in the lab, and the other one can be natural. Natural means that we obtain from the nature. So it can come from plant, microorganism, as well as animals. So I'm a phytochemist, natural product chemist. So basically, we are studying the chemicals derived from plant. Okay, so why plant produce chemicals? So there are three main reasons actually. First is for the build-up structure. We call it primary metabolite. So it is actually involved in the physiological function of the plant, right? So for instance, we know that plant contain carbohydrate or it produce carbohydrate through photosynthesis reaction. Okay, and this carbohydrate or in the form of glucose is actually used for is actually a fuel for the plant so it can grow. Now, second is for defense mechanism. So we know that plant contain irritants, spines, waxes, gum. So, for instance, here we have this chemicals. It's been called suberin. So it is the latex that we have in our jackfruit. Next is actually for defense mechanism. So for defense mechanism, this is the type of metabolite or chemicals that we are keen into it, or we call it phytochemical if it came from a plant. So why actually plant is producing this secondary metabolite or this kind of chemical from plant? So we have polygion. So polygion is actually from this mint. It has a warm scent, okay? And then we have citric acid. So citric acid that giving a bold taste to our lemon, the sour taste. Okay, and then we have tannin. Tannin is if you see there in most of in your tea, we have tea as well that is called tannin. It is a strong antioxidant, and in our plant as well. So we have banana here. So when the banana is actually extra ripened, it's going to produce these dot spots. So the dot spot is actually preventing. It's just a survival actually for this particular banana to continue surviving because this tannin exhibit antimicrobial activity. Now, we as a phytochemist, we interested to learn about plant chemicals because history has shown that plant is the source of medicine. So this is Kemunting China, right? So Kemunting China has given us a vimblastin. So vimblastin is used as a chemotherapy drug. Okay, and we have weeping willow bark. So if you went to any park, go for jogging, so you're going to see this tree is actually been planted nearby our park there. So the bark is actually producing salicylic acid. So this because of the it's difficult to absorb, our body take time to absorb salicylic acid. So chemists modify it, produce aspirin. So aspirin is actually the world most consumed drug in our daily life. So it is a painkiller, yeah. Right. We also have pilocarpine. So pilocarpine is a stimulant, a stimulant to secrete saliva and sweat. So it is isolated from Maharam jaborandi. We have quinine, anti-malaria drug, isolated from fever tree. And last but not least, we have cocaine. Cocaine is actually a numbing agent, so it is isolated from coca leaf. Right. So history has shown us that more than 50% of the drugs that are available now that being consumed is actually came from plant or natural resources. And artemisinin is actually a gift from traditional Chinese medicine. So this is a professor which actually Tu Yu. So he won a Nobel laureate in 2015 because he's discovered this artemisinin. So because of this artemisinin, been discovered, so it can help to treat malaria. So the drug actually has saved millions of lives in South Asia, in China, Asia, Africa, as well as America. Okay, so let's move to our food again, right? So we are still there. As I mentioned just now, so our food is actually made of chemical as well. So these natural chemicals are champion without you knowing it. Actually, they are making our food colorful. We have this different color with blue, red, yellow, green, whatever it is. It gave us a very good taste and palatable and keep us healthy. Without, of course, we don't knowing it, right? So why it make us healthy? It contain natural chemical just now, particularly on the secondary metabolite. Okay, the most prominent function of this, common natural chemicals is actually as an antioxidant. So if you're familiar with cooking or all the flavors giving herbs in our in our food, so we have oregano, we have rosemary. So the antioxidant property of rosemary is actually due to rosmaric acid. We have phenolic acid from barley seed. Okay, we have catechin from tea, uh, thymol and carbachol from oregano, and from kasum we have methyl galate. So those who like to eat laksa, you have that methyl galate inside there. Now, other than giving us, nutrients, so we can our cell inside our body can function well. The the chemicals in our food actually can tell us that the food is actually rotten or not in optimum state. For instance, here this is beef. Okay, so if you see here, we have different color. You have slightly red, and then this is already brown, and then you have slightly purplish. Yeah. So this is actually due to the changes in the chemical property of our complex compounds, or also called the organometallic compound. So if you see here the iron, okay, which is actually transporting the oxygen, we have oxymyoglobin, which is giving us the red color here. When it deoxidized, means that removing of one of the oxidation state there, so it's going to give us this purplish color. And then if it's further removing electron from the iron at the middle of the structure here, so they're going to give us myoglobin, so telling us that it is not fresh anymore. Okay, so the chemical as well can give a smell. So we have banana, when you have a ripened banana or pear or apple, that sweet smell that we can sense is actually due to the ethylene compound. And those who like king of the fruit, which is durian, so all the flavors, smells is actually due to this natural sulfur compound. Okay, and if you're cutting your onion, so the one that give uh, uh, that cause a cry is actually due to this sulfurous compound. When we cut the cell of our onion here, it's going to release this chemical, and it volatile reach to our eyes, and the eyes going to predict going to um, say that there's an invader here, so defense mechanism of our body try to release the tears, so to remove this particular chemicals. Okay, so the chemical as well can give us different taste. So citric acid, that's why our lemon or orange is actually sour in taste. Capsaicin giving us that hot taste, okay, spiciness. Fructose, which is two times more sweeter than our table sugar, sucrose. So that is the cause of most of our fruit and vegetables are sweet. And those who don't like this bitter ground, okay, so the bitter taste is actually due to this cucurbitacin compound. Now, cocoa. I believe most of you like to eat chocolate, right? So the bitter taste in the cocoa is actually due to this theobromine compound, which is actually also a good antioxidant. And those who don't, controlling their table sugar level in their body, so they are using stevia. So stevia is actually giving us stevioside. So stevioside is actually powder. This is the structure of the compound. So it is actually 200 to 350 times sweeter than the table sugar. That means that it has no calorie. Um, and if you take a little small amount, actually it can give a sweet to our taste comparable to sugar, the table sugar itself. And we also can touch chemicals, right? So if you see here, this is okra, lady's finger. If those who like it, of course, it is okra is actually very significant for having slimy texture, right? So the slimy texture is actually due to this epoxy polysaccharide constituent inside there. So it been produced if there are water. So in order to reduce these slimy things, you need to avoid having water in your okra. And capsaicin, it can also, other than giving us a palatable taste, spiciness in our tongue, it's also if you touch it, it's going to give us that hot sensation. Okay, and this all of this chemical in the food or in the plant is actually changing. So how do you know? How do we know that it is changing in the constituent? So basically, due to the color changes. So we have this chemical bell pepper here, right? So the color, the aroma, and actually flavor are due to this particular chemical presence. Okay, the green color is due to chlorophyll, right? And when we have this yellow bell pepper, that is actually due to this lutein and biolactacin. This is actually the similar compounds that we have in our yolk. Okay, and the one that in red color is actually due to this capsaicin. And other than changing slowly, naturally, you also can see in your food, the color changes is due to actually chemical reaction that occur depends on the environment of the food that we have. Right. So I'm going to give an example on pH sensitive chemical, which is the purple cabbage. So purple cabbage here, it contains an anthocyanin. So anthocyanin is actually a very sensitive compound to pH. This is because of the oxonium cation that we have here. Now, this is the anthocyanin just now. So if our purple cabbage just now we cook in something that very acidic, means that we put some um, vinegar, or we add on some acidic substances, what will happen? The color of the purple cabbages now is supposed to be purple, it's going to change to red. That is because of this region just now. And if we slightly do some dilution, you can see that due to the structure changes, it's going to change to different color because it is reaching 4 to 5 pH. and it's going to give us purple color when the pH is almost neutral because of the changing in the structure of our anthocyanin compound. And if we reduce the acidity and increase the basicity of our purple cabbages, now it's going to turn to blue color because of these changes in this particular structure. You have an OH here, so this one is become O minus. And if you increase the basicity, means that it's going to reach basicity reaching to our detergent, so the color going to change into yellow. So that is because of the opening of the spiron structure there. Now, because of that blessing, you actually can use purple cabbage to predict the pH of a solution. Okay, more examples I like to give you. So, because we are talking about natural compounds and the food as well. So, I don't know if you have tested this magic fruit. So, this particular magic fruit is actually containing curculin or glycoprotein. We call it magic fruit, right? So, if we take this fruit, you put it in your mouth, so it's going to change any sour taste to become sweet because this particular compound here is going to bind into our receptor in our mouth. So whatever things that you eat after that is going to give you sweet taste, including medicine, which is a bitter. Okay, and right, so because we are eating every day, right? We are eating every day. We don't know what are we eat. Is it enough, or we actually eating it in excess amount? So do you know that actually food can become poison as well? So we have this glycoalkaloid. Right? Glycoalkaloid is actually belong to we call it solanin. So it is containing in brinjal or eggplant. Okay, that is particular the compound is there. So those who have experience, some itchiness in your mouth when you eat this brinjal is actually because of this solanin inside um, uh, the brinjal. Tomato, which is unripe, they also contain glycoalkaloid. Okay, so it also can cause that itchiness. And we have our potato. So the potato, whenever you see a green color of the potato, you don't eat it. Because it also contains glycoprotein. The green color is not actually due to the glycoprotein. It's actually a glycoalkaloid. It's actually due to the chlorophyll. But the function of this particular glycoalkaloid is actually it's a defense mechanism. The plants is going to sprout, it's going to grow, so it uh, for that it's going to release this solanin type of compound. So we shouldn't eat it. It's just like that. So it can grow. So this is focusing on the sustainability of the plant as well. So if you cook it, it's not going to be the nature because it is very strong. I mean, it's not thermolabile. So how you going to consume the potato? You just remove, just cut on the green side, then you can consume it safely. So as I mentioned just now, this glycoalkaloid is going to cause itching in the mouth, dizziness, nausea, vomiting, diarrhea, and stomach pain if we consume it too much. Next, we also, I believe most of you like this bamboo shoot or, tapioca shoot. So, do you know that actually it contains cyanogenic glycoside? So, for instance, here we have linamarin. So, linamarin is going to decompose and produce hydrogen cyanide. So, this hydrogen cyanide is actually giving us the bitter taste of these two food. So, the bitter the food, the more bitter actually these two food, it telling us that more hydrogen cyanide is actually containing in the food. Right? So, it can cause respiratory and cardiac system disorder, symptom related to poisoning, for instance, dizziness, stomach ache, vomiting, diarrhea, rapid breathing, as well as drop in blood pressure. And it can also cause fatal to some people that are very sensitive to this particular hydrogen cyanide. Now, conclusion. I'm moving to the conclusion now. So, our food can become food as well, can become poison. It depends on the amount that we have, it's the dose. So, as been mentioned by Parasius, so he said that all things are poison and nothing is without poison. Only the dosage alone that make it to be poison. Okay, so this is basic principle of toxicity. If you see here, This is honeycomb. So honeycomb is giving us honey. People think that because it is honey, so it is safe to consume that much, especially those who are having diabetics. So we know that honey is safe contain high amount of fructose. Okay, it contain sucrose, and that sweetness is due to this particular sugar. So high concentration of fructose is actually going to disturb our body function. So you don't consume too much, just enough, right? Then we also have because I was talking about all the natural food just now. So people are also like to consume processed food. So all the processed food is actually containing additives. So you have that all the E series. So as I mentioned just now, you can eat in moderation, but don't consume it over, because our body, some of this particular additive, it can bioaccumulate in our body and disturb the function, the natural function of our body. So the conclusion is actually whether food itself giving us energy and make us healthy, it depends on the dose, the amount that we consume. And also it depends on the individual tolerance. We call it threshold, because some people can, when they consume it in a very small amount, it can experience that bad effect. But some people, they need to take in higher amount to cause the same effect that the other person experiences now. So with that, I would like to thank you for listening to my sharing. Thank you so much.
Thank you, Associate Professor Dr. Fatima, for your interesting sharing and talk on chemicals in your food. At least now we know what is inside the food, what are the good one, what are not so good one, what are the bad one. So if you love this type of talk, so follow the series Mama, which is I would say the main speaker will be Associate Professor Dr. Fatima. Anyway, do you have any question for the floor? If there is none, thank you very much, Associate Professor Dr. Fatima, for the interesting talk. And actually, this Mingguan Science Negara IKN is organizing series of talk. This week there are two. Next week there will be another one, and I will be next week Tuesday 10 o'clock on the role of forensic chemistry in criminal investigation. So you are welcome if you are interested to know a little bit about forensic chemistry. So Dr. Fatima, I thank you very much for this interesting talk. We hope in other audience will share your this interesting topic in another occasion. Maybe not all are around because due to other job commitment during weekdays, whatever it is. And with that, I would like to close the session on today, Mingguan Science Negara, especially on the Mingguan Science Kimia, Malaysia. Thank you again to the organizer, Associate Professor Dr. Fatima, and everybody who have attended this interesting topic for this morning. Thank you and have a good day. All the best.